Hey guys, so today we'll be learning about trig identities, which I'm sure every one of you loves to work on, right? Of course you do. Alright, anyway, so today we're just going to be talking about what a trig identity exactly is and what it's used for, and I'll give some examples. So let's begin. Trig identities. So the book definition for a trig identity is an equality that occurs for any trig function. And it is true for all values of the variable. And you'll probably see the variable written as usually theta, but today I'll just use x because I'm sure that's what you guys are more familiar with. And yeah, so that's what a trig identity is. It's basically saying that one thing equals another. That's the equality part. And we use them because we can rewrite some complicated trig functions into making them simplified or equal into something else. So yeah, that's basically what a trig identity is, and there's a lot of them. So let's go ahead and get started. We'll start with the reciprocal identities. You should already know a lot of these at this point in the year of pre-calc, but we'll go ahead and go over them again. Alright, your first one is sine x equals 1 over cosine x. Alright, go ahead and write these down as I go through. We also have cosine x equals 1 over secant x. Tangent x equals 1 over cotangent x, which also equals sine x over cosine x. And yeah, that's about it for the reciprocal identities. Of course, you can rewrite these in many different ways, but we'll probably do that later. Alright, next we have the Pythagorean, hopefully I'm spelling this right, Pythagorean identities. Yeah, there we go. So, Pythagorean identities, there's 6 of them actually. Well, actually 3 of them, but here, I'll show you. Sine x squared plus cosine x squared equals 1. You've probably seen this one before. This will be one of the most important identities you'll ever deal with. It'll come up a lot, let me just tell you that. And you have tangent x plus 1 equals secant x. Also have cotangent x plus 1 equals cosecant x squared. Yeah. And of course you can rewrite these in many different ways. You can bring the 1 to the other side, bring the cosine squared to the other side, and yeah, so forth. So these are all the identities we're going to deal with today. So yeah, I hope you have them written down. Let's move on. And I'm working especially slow today because I know my experience taking pre-cal and coming up to this unit all of a sudden, it was rather difficult because you sort of just jump into all the hard problems. You don't really get much work with some simpler problems to get you understanding the basics of what trig identities really deal with. So, we're going to do some little simple problems right now, and as easy as they are, I want you to pay attention to how they come up now and how they can come up later. Because you'll probably see something of the like. And you'll probably deal with a lot harder problems. But for now, let's deal with this so you know how to approach the harder problems. Alright, I'm done talking about this. Let's go. So, simplify. We'll start out with secant x cosine x. Okay? So, immediately you can see that there's an identity you can use. And that's one of the reciprocal identities. Secant x equals 1 over cosine x, and this is derived from the one earlier. Whoops, I should have wrote this first actually. So, yeah, but these two are pretty much interchangeable like this. So let's go ahead and use this identity. 1 over cosine x times cosine x. And that, of course, is 1. Easy enough. Next, we have some proofs. And don't get scared when I say that word, because these aren't like the proofs that you did in geometry. You don't have to make those crazy t-tables and that kind of thing. But instead, you're going to be proving that one side of the equation equals the other. So for example, we're going to prove that tan x cosine x equals sine x. Alright? And, usually when they, or actually always when they say prove that, they're not tricking you, okay? It actually one side of the equation actually equals the other side. You just have to figure out how. It's like they give you a completed puzzle and you need to figure out how it was put together. They're not gonna trick you and say, oh, this actually doesn't equal each other when we said it did, Okay, so let's move on. Tan x, we know, is sine x over cosine x. And then you have another cosine x. So, what does that become? Sine x, of course. Yeah, see, these are really simple for now. But, I hope you're seeing which trigonometric function you should be manipulating. You can't really do anything with the cosine or the sine for now. So what do? You go towards the tan x, of course. Alright. Next one is also rather simple, but it's a little more tricky. Alright? Sine x, cosine x, tan x. Yeah, I know, that's really ugly, right? Equals 1 minus cosine squared x. Alright? So, just like the last problem, you have a sine, a cosine, and you have a tan. But you can't really do anything with the sine and the cosine. So go ahead and manipulate the tan x, of course. So sine x, cosine x, times sine x over cosine x equals 1 minus cosine squared x. There you have it. And what you want to do now is, of course, cross out. And you have sine squared x equals 1 minus cosine squared x. And if you didn't realize, we could rearrange Pythagorean identities. You'd be like, wait, what? What's going on here? Can't go from a sine squared to a cosine squared just like that. But you can, because the identity is sine squared x plus cosine squared x equals 1. like I said, you can rearrange these equations and make that become sine squared x equals 1 minus cosine squared x, right? So yeah, just move that over. And these two equations are exactly the same, right? Awesome. So, I have one last example for today's lesson, and this is really one that you have to have a little bit of experience to see at first, but I'm gonna go ahead and work it out, and you guys may be wondering how the heck I came up with this, but this is just something that came out of practice, I guess, and because I wrote the lesson, but whatever, let's keep on going. So cosecant squared x minus 1 all over another cosecant squared x equals cosine squared x. Now, there's a number of things you can do here, but since we're working with identities, I'm gonna go ahead and just change up this cosecant squared because I don't like that. Yeah. Another thing is, if you're not familiar with the secants and the cosecants, it's probably a better idea to convert them into their sine and cosine forms whenever you can, so you know how to deal with them, right? So cosecant squared, that becomes 1 over sine squared x, right? All that minus 1. And then you have another cosecant squared, so 1 minus sine x squared. And of course that equals cosecant squared x. Okay. So now that we have this, and since the denominator is one term, okay, if your denominator was a polynomial, for example, and it had multiple terms on the bottom, you couldn't do this, but what I'm going to do is I'm going to sort of separate the fraction. So what you have now is 1 over sine x squared over 1 over sine x squared minus 1 over sine x squared. And this, of course, is 1, right? Because two the same terms divided on each other. That's 1. And then this becomes sine squared x, right? Yeah. Same thing when you divide a fraction, same thing as multiplying by its reciprocal, right? So 1 minus sine squared x equals cosine squared x. There you go. Yeah. And you can probably guess which identity we need to use now, right? Of course, the sine squared x plus cosine squared x1 equals 1. Yeah, see, I told you it would show up a lot. You can go ahead and rearrange this equation. Oh, whoops. It'll actually be flipped, but cosine squared x equals 1 minus sine squared x. Alright? So now you have the two equations that equal each other, and your proof is finished. Alright, so that's all I have for today's lesson. We didn't really go into much detail, but I hope these basic problems, they really got you thinking about when we need to use identities and what they are used for. So, yep, today's introduction to identities is finished. Alright, thank you guys for watching.